which we did earlier, and this present you might find it helpful. So if you and I think this should be a more interactive session. So if you have any questions, and if you need to know about anything in more deep like that, please post on the chat to unmute yourself and feel free to speak um, today. And I will share some experience and maybe even more details with you. So let's talk about it. And if you do have questions, please interrupt and ask, and or post on the chat, right? So you all know we discussed about the Arduino. It's an open source platform which is easy to use and easy to program. So the Arduino board itself, I think I told you already, it's designed for not for engineers but for artists. And the main target audience for Arduino is not the people with an electronic background. It is designed for people without electronic background, so that they can bring their ideas to the real world. Maybe someone need to water their garden automatically. So if they do not have electronic knowledge, they can use the Arduino and maybe try to get the help from the community and do something like that and construct their idea, right? So a basic example I can tell you, which is more familiar with you, is you might have heard about the circuit called the multivibrator. That is a circuit which has two LEDs, right? Now these LEDs toggle between one another. So when this is on, this is off. When this is on, this is off. It happens repeatedly. This circuit is constructed using two transistors, two resistors, four resistors, and two capacitors, right? And the on and off time of this are determined by the RC constant, which we call the time constant of a capacitor. Now, as you that we call tau, right? This is the time constant of a capacitor, and there are more equations to that, of course, but I'm just sharing the idea with you. So anyway, right. So what I want to emphasize is that it is really hard. It is really not easy for someone without an electronic knowledge to do this, right? So with the Arduino we have already created this circuit, and it is just a few lines of code. With those circuits, those are additional things, right? Okay, so moving on, that is the main advantage of the Arduino. And other than that, when someone needs to like do something more advanced, like publishing something to the web, maybe sending a Twitter message or something like that. And let's take an as an example, there are applications where we post our sensor data to the internet. And if you can get clever, you can even post something to Twitter, Facebook, or something, social media, even with the Arduino, right? You don't some the main controller we usually use is a Raspberry Pi, but with the Arduino you can do that. You have to enable Wi-Fi or connect to it to a LAN, but that is possible. So those things, of course, you need to have some kind of advanced programming knowledge, but with the help of the libraries and from the community, you can do that, right? So the main advantages is it's fairly inexpensive. It is a bit expensive, but the trade-off between how many projects you can do and the price, that is really fair, because with the Arduino you can do many projects, right? So it is really easy. So in the programming environment, the IDE itself is really simple. We just have the compile button and the upload button, and there are add library and stuff like that. But when you take something some more advanced IDE, I will show you one. Those things are really advanced. There are like debugging sections and communicators, terminate MCU termination and stuff like that. Those things you might not know, but that is pretty complicated. So that is the main advantage of using an Arduino. So it is open source, so anyone can use it. And you cannot resell it, as I know. You cannot use the name Arduino and resell it, but if you construct some kind of a circuit around the Arduino board and put your own name on it, you can resell it. You have the master resell rights, but you cannot use the name Arduino. That is why there are other Duinos, right? There is a board called Arduino that is from a Chinese company, and even in Sri Lanka, there is a board constructed by Lankatronics, I think, that is called the Arduino. There are different versions of that. Some Well, that is important because some of these boards have their own advantages. For example, this is this might be a bit complicated for some people, but just try to understand it. The Arduino boards need the chip itself. The big black chip on the Arduino Uno board takes 5 volts, right? And there is a 3.3 volt pin too. This is not used by the chip, but we need that. For sometimes we need it. So anyway, in the original Arduino board, the regulators are called AMS 1117 3.3. And for this, I think they use, this is for 3.3. For this is, they use AMS 1117 5 volt. So these regulators are not that good. These are from Advanced Monolithic Systems, that is a company. But these regulators, this is a really small chip. You can find it something like this. This is a voltage regulator. You feed the voltage in. This is the ground or something like that, and you take 5 volt or 3.3 depending on the chip you take, right? So these are simply voltage regulators. When you input like 9 to 12 volts, they output a certain constant voltages. These are actually called the LDOs, the linear low dropout regulators, right? So these are not that efficient, but the output is really stable and really smooth. That is why we use them to power MCUs. Anyway, the chip AMS is not that good. This is on the original Arduino board. So as an example, the Arduino board use a separate much more durable. Tell you the modifications, and you have female header pins on the Arduino board. Some Arduino boards they are with male header pins, right? They change the architecture and the construction a bit, and that is now the definition of open source, but that is the basic idea. And yeah, here it is much closer to the English language we speak and easy to program in that case, right? So this is the documentation page in the Arduino website where you can download Eagle files. Mean the Eagle is a software which you can use to design circuit boards in a basic level. It's a really simple software. You can draw a schematic and convert it to a PCB and get it manufactured. These boards are designed in Eagle. These boards are a bit complex, but Eagle can handle that. And these are the schematics in PDF, and you can download the board size in DXF. DXF is a CAD format, right? CAD means computer aided design. This is used in AutoCAD or softwares like that. So the use of this DXF is really important. If you make a shield that can be plugged top on the Arduino board, you should use this file to locate the pinholes and pin headers and stuff like that. So please mute your mics because I am getting some interference. Right. Thank you. So this is a screenshot of the Eagle software, and this is the Arduino Nano board, right? So these red lines are on the top of the board, blue lines are at the bottom of the board, right? You don't need to know these things. I'm just showing you the depth of this thing, right? Just for your interest and to do a little bit of a recap. These are the header version of the chip or something like that. You can do that. It is acceptable and not like restricted. This is the PDF schematic. See, this use a LM 1117, maybe a bit better than that, right? There are stuff like that. So here is a photograph I took from competition. This board is called the Arduino, right? They constructed the board and they gave their own name. So these are the things you cannot do with the Arduino. Image processing you cannot do. This cannot handle that much of processing power. But there are some instances where you can take an image and maybe grayscale that or do a little bit of processing. But that is a really something that you should not try because it is unnecessary, complicated, and really useless, right? Product processing is used in factories and large scale stuff like that, and highly classified security or sensitive applications like navigation systems or military applications you should not do with the Arduino board itself because that is not acceptable. But when you think about it, the Arduino board is made from a chip called the 80, I mean the Arduino Uno and Nano boards are made from a chip called 80 mega 328 PA and MU 328. The Mega has PU and the Uno has MU. This is the package sizes, I think. Anyway, if you use that chip and not use the Arduino is kind of a middleware, right? It is a it is something you can understand and the chip can understand. And if you know, that is the common language both the chip and the user understands, right? So it is like a some middleman, right? The Arduino itself is not a language. No, it's like a trade name. Anyway, the language is a C variant. That is something you and the chip understand. The chip understands that because there is a bootloader. That is something we call it. There is a bootloader in the chip, and there are some instances you can delete the bootloader and program it directly to the chip without using this Arduino stuff, right? Then you are using just the chip, the ATmega 328, and we call that bare metal programming. It is really advanced, and there are some advantages of that, and disadvantages. It is really complicated and really hard to do that. You cannot use digital write and digital low and stuff like that. There are nothing like that. You directly address to the registers of that and make it work, right? When I say registers, it is I will it's like a bookshelf, right? It is divided maybe into 8 or 16 sections. That is what we call bits, and you can give it a value, maybe 1 or 0, right? There are output registers, input registers, and like that. If you put 1 in output registers, that pin becomes high, and when you put 0, that pin becomes low, right? This is the basic idea. Anyway, digital write and digital read, they handle that for you, right? So you don't have to do that. If you had to do that, it's really hard. So that is what the bootloader and this nice programming language does. So yeah, I think you got that. Anyway, these are more in-depth information. You really don't have to know these things, but it's nice to know. This is a video I want to show you, I think. So these are Arduino projects you can do.
And the power's on, and our door is locked. If somebody comes by and gives a regular knock, nothing happens. But if they come by and give the secret knock, the door is unlocked.
What's your name?
This is a really interesting project. This is called the Micro Mouse, and now it is becoming popular even in Sri Lanka. So, but this it is going to take a test run and a mapping run, and then it's going to find the shortest path from the start to the end. This is a 3D printer, and those are things are now based on Arduino Mega boards. There are some based on this TM32 family, but most of those things are based on the Arduino Mega. That is what we call the ramps shield. You can even build one at home, but this is called an accelerometer machine. So these are the types of Arduino boards. I couldn't show you images before. The Uno board, you all know this, and this is the Nano board. The Duke board, this has some more memory than even than the Mega board, and Lilipad Leonardo board. The specialty of the Leonardo board is there is a you see even in the Mega board there is this little chip. This is called a 16U2IC, or the part number of this is port. The has that inbuilt. So this has a direct access to the USB port. The advantage is you can use the Leonardo board to make stuff like keyboards and mouse and like that. So these are the digital and analog low, that is from 5 volts to 0 volts, right? An analog signal has the intermediate values. Even if we start from 0, that can go from 0 to point 1, point 2, like 1, 2, 3, 4, and to the top, and then back. Then it goes a negative cycle sometimes, and like that, right? The role of a Arduino. Okay, I am getting some questions. What you can do with the lily pad, right? The lily pad is called the Arduino wearable. It has limited outputs and limited inputs. Because it is really small, you can maybe connect and have it on a drill. That is why it is called the Arduino wearable. Some people make wristwatches with that, I have seen. And a common application and a real nice application I saw recently on a forum was a baby tracker. Not like a baby alarm, or kind of a one guy had programmed it, two of those things, and he had found some version from a third party company with inbuilt Wi-Fi or Bluetooth, and he has a little baby. When he is browser for the board, and he ties it to her hand, and when she goes maybe like 10 meters from the reach of him, it is going to beep, right? So he can look for the baby, and it's not. really important because you can of course keep an eye on the baby, but it's a good thing. But anyway, there is application like that, and or something like that. So yes, there are applications, and when you have an idea, you when you get creative, those things you can use. So the yes, you can program it with the Arduino IDE. All those Arduino boards you can program with the Arduino IDE. And yeah, the basic ways, the basic the basic thing the Arduino does is it is really simple, right? It can read voltages from the input bit, digital low analog voltages, right? Digital high, analog high. We read and digital read, and we use analog read, right? We use both of these things. We did those actually. That is why I am this presentation today, because already know these things, and you can set the state of the output pins, right? You can either digital out set digital outputs like high and low, or you can PWM and make like things dim or like that. Like maybe speed control has an internal clock and the external clock. By clock I don't mean a real clock which has hours or stuff like that. I mean a clock signal, right? A clock signal is something, it is a pulse wave, right? It is a wave like this, and this amplitude and the wavelength is fixed. The frequency is fixed. In Arduino, we use a 16 megahertz. Yeah, 16 megahertz. Yes, 16 megahertz clock. So it means it has 6,000, right? No, 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 not 6,000. Wait, yeah, it does this much times for 1 second. I don't know how to read this number anyway. So that is the frequency. So that is what I mean by the clock, right? It has an internal clock to internal and external clocks. We use the external clock to count the time, and like maybe when you type digital, not digital, when you type in delay 1000 milliseconds, it is the it is the clock that is the Arduino is referring to take the timing, right? And there are communication ways. SPI we didn't do, I2C we didn't do, and there are wireless communication ways. You have to fix external modules. Right. These are the digital values, right? 50, true, false, 10. These are like, this is how we refer. Anyway, the digital value is something. A digital value does not have to be between just 5 or 0, right? It can be 3.2 to 0. It can be 12 volt to 0. It can have just two values, not intermediate values. That is the idea of digital. Even an analog value, it does not have to be between 0 and 5 volts. It can be between 0 or any other volt, right? It should have intermediate values. Like when you draw an analog signal, this is the time axis, this is the voltage axis. You draw it like this, right? This is an analog signal. So a digital signal is something which has only two states, right? These are the outputs, digital outputs. We have PWM. A duty cycle is the ratio between the total time and the on time. I talked about that, but let's talk about it a little bit more. The duty cycle is the word I want to discuss more, right? You know already what a PWM is: pulse width modulation. We modulate the pulse width, this width of a signal, right? And we use that. So when you hear the word duty cycle, what you should know is, now it is a ratio. It is a ratio between the on time a signal like this, right? And the period is let's say 1 second, right? And it is on for half a second. What is the duty cycle? Anyone? Right. So we have a 50% of a duty cycle. That is where only work happens, right? So that is why we call it the duty cycle. In the complete cycle, the duty happens only in a 50%. So we say we have a 50% of a duty cycle. and those things can get boring. So with other modules, right? I can say a little bit about that. I2C we use usually two lines. I actually can tell you a little bit about that. And we have a master module. Maybe we use right. We use Arduino Uno, and S1 means slave one, slave two, or slave three. Now tell me, if I want to send some data to maybe S3, I can hook up as many items as I want here. Let's say I have n items, Sn. How do I between all these modules? How can I like identify S3? What is the special give this to one? How do we do that? Like, think of this as a street, right? You have a street and you have multiple houses. When the postman is delivering letters, how can he know which letter goes to which house? What is the exact thing that like designates each house? What is unique of the each house? If he the shape, of course, but the address. Yes, the address. So we give these things address. Usually they look like this, right? In the I2C communication, we give these things addresses, and those addresses can be adjusted, of course. And we can maybe if we tell this to the 3F, so all these things see that information, but they do not care. Only the one with the relevant address is going to take action, right? There is the other way too. If I want to send from S3 to the master Arduino, it is going to send with its address. So all these modules going to see that signal, but they do not actually care because it is not sent to them, right? That is also the case with the SPI communication, but this is bit more fast than the I2C protocol. I2C is easier because we only have two wires. We have a serial data and we have a serial clock. You have seen this SBA and SCL pins. This is analog 4 and 5 on the Arduino Uno. Uh, so that is about I2C. SPI use like four wires, and sometimes you can use three, but usually you need four wires. RF uses like radio frequency, it is wires, and usually most of the Arduino modules you have to connect with using SPI, but it is going to communicate with the other Arduino wirelessly. So we are going to do these things later, and we are going to communicate between Arduinos. I am just telling you the idea right now. Here you can see the analog 4 and 5. These two pins are reserved for I2C communication. So if you do I2C on Arduino Uno or Nano, you cannot use those things for analog reading, right? You have to reserve them for I2C. And the SPI pins I can show you here. These are the SPI pins, right? MOSI means master out slave in. This is master in slave out. SS is a system clock. SS is a select pin, and SCK is a what clock pin. Yeah, this is the Uno. We have the I2C pins, and here we have the SPI pins, right? And there is another interesting pin called the interrupt pin. Did I talk about the interrupt pin before? Can anyone remember if I did? Interrupt pin is a pretty interesting field. Can anyone remember? Right. Anyway, I will talk about it a little bit. So, code. Uh, Let me go to a more empty slide. Yeah, here, let's do that. So, you can write a code like this, right? So, if you want to read a pin, you can write digital read pin 3, right? This is going to it is going to read the state of digital 3 and give it to you. It is absolutely fine, but there is a drawback of this, all right? The thing is, the Arduino is constantly going to check if what is the state of the digital 3 pin, and sometimes you don't need to do that. So that is unfamiliar with you. So let me tell you that with the example. The common example we usually use is using a cell phone analogy. Imagine you are supposed to get a phone call from a friend, and there are two ways you can receive that, right? You can either check for the phone call periodically, maybe for 1 second. For each second you are going to take out the phone from your pocket and see if a call is coming. If you see the call coming, you can answer that. Assume you don't hear the ringtone, right? So for each second, you are going to take out the phone, see if there is a call coming, and if not, put it back in the pocket. But in interrupt, that is different, right? You are doing something else. You are doing your usual daily routine, and if you hear the ringing tone, or if you feel the vibrate or something like that, you are going to answer the call. That is interrupt. So it does not affect your daily routine, right? You can do your daily routine and still care for the interrupt. That is the case even with microcontrollers. If you do polling, that is digital read, that is a polling technique. We call that polling because for each cycle of the void loop, we check if that condition, what is happening with that condition. So for polling, you are going to waste system memory and system speed, but for interrupts, you are not going to do that. If you get an interrupt, if you hear the ringtone like that, there is a thing you want to do, right? Like the answer, like in the cell phone analogy, like you are answering the phone in a microcontroller, you might need to do something. That is what we call the ISR, interrupt service routine. So don't mind these things. I'm just giving you the background knowledge. So these words don't take you by surprise when you do these things with the practicals. So these are sensors of the Arduino board. This is a MPU 6050 gyroscope, humidity sensor, temperature sensor. This is a load cell. Anyone know what is a load cell? Why, for what this is used? Anyone? A load cell is used to measure loads, right? To measure weights. In our like home scales, like weighing scales, you have four of these for the four legs or the plate, and that is how you measure the weight. This is a pH sensor and amplifier. This is to measure the pH of a solution. This is CO2 sensor. This is a fingerprint reader. This is a ultrasonic sensor, which is really popular. This works as the as how a bat finds its way in the dark, right? This is a touch screen designed for the Arduino boards. So these are Arduino Shields, right? There are a lot of shields. These are the shields by this Spark Fun company, right? Here is a nice demonstration about how we use the sorry, the breadboard. This is how these two rails are connected, and this is how these others are connected. Now this image describes it much more nicely than I did with like the manual drawings. The IDE, we are familiar with this, right? Blinking an LED. So these files, right? So discussing about the code, I will do this just barely for one more time, right? You initially set the output pin, right? Pin mode 13 output. If you don't do this, the LEDs are not going to blink enough, right? Like won't light up that much brightly. So you do have to declare outputs as output, and you can give this a name, but here we haven't done that. Digital write 13 high. You make that pin high. Wait for 1 second and then make it low, right? So there is one other thing I didn't tell you earlier. When you type in a delay in Arduino code, the Arduino board is going to freeze for 1 second, right? It is not going to do any other thing in this 1 second delay. That is why when you get more advanced with the Arduino, there is a thing you do. It is called ditch the delay. Ditch the delay means you don't use delay when you get more advanced with the Arduino environment, right? The delay is going to freeze the Arduino code or the entire MCU, the microcontroller, right? So, but this delay is doing something a bit more like useful. That is, when you write a really long code, maybe like thousand, ten thousands of lines. Usually at the end, if you even if you don't use delays, we usually put like a delay of maybe uh, 10 milliseconds, 10 of 5. Really small type of delay we use, right? Maybe 5. That is we call the breathing room. When the Arduino board is executing a really long code, it is the MCU is like doing a lot of work, and it stresses out, right? As a human, it is going to stress. This is electronic stress, not a mental stress. So At the end we need to give it a little bit of a rest, so that is why use a really small delay at the end of a loop. Usually if you don't use delays in the main code, we usually put a really small delay for breathing room or breathing time for the Arduino. Sometimes you have to use the delay, you cannot ditch it because some sensors take time to establish, like the oxygen sensors, they need some time to establish. There are some techniques where you can ditch the delay even for them, but sometimes it is much easier to do a delay. There are some applications which are not time sensitive, like which you can actually drive. So if we had used delays there, imagine what would happen in a 5-second delay when you want to apply brakes. It is not going to do anything. So there are other techniques where you can ditch the delay and give all the other things are going to turn off, and the braking function is going to turn on, and the braking function is going to turn off, and all the other things are going to turn off, and the braking function is going to turn on. There are techniques where you can use the delay. It's all right, but there is example where we blink an LED without the delay. So when I get to that, I will explain a bit more things. So here is the this is how we name the LEDs, right? When you say red, all these reds are going to be replaced by 6. So we can name them, but the idea is going to see this red as 6. It's really easy to use this. This is a for loop, right? You have to use this for loop, this is how you cycle, zero duty cycle. You don't do work anywhere. In a 50%, 25%, you are doing like 1/4 of the time you are doing a duty, right? This is a 50%, 7%. When you do a duty 100%, the LED is off here, off, and this is fully on. Let's take this, right? This is the middle brightness. You can see the LED is turned on and it is doing work only 50% of the time. That is like half the brightness compared to this. Now I think you get the complete idea. If you still don't understand these things, please do tell me. This is how you fade an LED, and I think we did this. Yeah, we did that. The if condition, we did that, right? The if condition, this is if you and now this is something you need to remember. If you say x equals y double equal, this is to say when x is equal to y. But if you write like this means x equals to y, so whichever value is in x is going to be added to the y2. So make sure you remember those things and use them appropriately. Else if we have done that, read in the button, and debouncing, we did talk about that. There are mechanical and software debouncing. So this is the Arduino reference I talked earlier. When you click this, when you go to help and click reference, it is going to open up this page. It is open from your browser, and you can click each of these things and read more about what those keywords do, right? Right. This is a toggle LED button. When you press the button, it is going to turn on, and when you press it again, it's going to turn off. We did that. So I will share this entire presentation with you, and you can try this by yourself. Right, this is something nice. So this is ideal button, right? When you press it is going to go to high, and this is a real world button. When you press it is going to bounce a little bit. See, so this bounces because these things are mechanical, and usually a button has a little spring or like a stressed surface. So it is a mechanical thing, and it is not to it is not to contact immediately. So it has some bounce, right? So that is why we have this bouncing problem. And when the not Arduino is not aware of this bouncing, so it is going to read this as high, this as low, this as high, this as low, right? And it is going to read multiple highs and lows. So it is going to give us a weird output. That is why use debounting. In a debouncing sketch, we actually neglect this area. We did one, and it's a really complicated code, but when we do the blink without delay, you can understand this. See, this is the debouncing sketch. It's really long. Actually, you don't have to use the debouncing sketch. There are ways to mechanical debounce switches. There are like add-in capacitors and stuff like that. You can mechanically debounce switches, so much better. Read in analog voltages, you all know that. So this is what we did in the last week. Read in an LDR, right? We couldn't do that because the LDRs didn't work, and I cannot show you the practical today because my other computer is having some problems. So these things we didn't do yet, but let me tell you what all these things do. So this is a night rider circuit. You know, these LEDs go from this direction to this direction repeatedly, and with this potentiometer, you can control the speed of of that pattern, right? So actually, you can try that at home. You know, it is not that hard. And the map function, let's discuss about that. So I showed you that in the last week. So we have this from 0 to 123, 0 to 255, and all those things are mapped, right? Those things are divided and work like that. As you expect, and thing I will do that in a later day. So these are arrays we didn't do yet because you need some more knowledge to do that. Anyway, we will do that. So these are called shift registers, and now it is getting a little bit advanced, but eventually we are going to do that. So let me tell you about shift registers a bit, right? So usually if you are going to control, here we have 8 LEDs, right? You are going to need 8 pins, right? So in the Arduino, you are going to waste 8 pins or use 8 pins, right? And that is something you cannot do in some cases. Imagine you have to make like a really big LED design circuit, and you have to use like 1000 LEDs. So obviously, even if you use the biggest Arduino, like the Arduino Duo or the Mega, you don't have 1000 pins, right? Oh, I don't think you have like 100 pins. Yeah, you don't even have 100 pins. So you can't control like that many LEDs from the Arduino itself. So you have to use a shift register. This is a really small one. This is actually 8-bit one. This can handle up to 8 channels, 8 LEDs. So to this chip, which is going to turn on these LEDs accordingly. And those pins, right? See, we are still using 3 pins, and we now have 16 LEDs. And if you want to do more, you can connect these things as in stages, and still they work like that. This is what we call the daisy chaining. It is a technique called that. It is what we call daisy chaining. So I will try to tell you how this works actually. It's a bit hard and you need the binary knowledge to do that, but we will do that when we comes to that, it's not that required right now. So to do that we need the array knowledge. We need to know how arrays work. So it is actually like representing the binary numbers from the LEDs. So it's not that hard, but let's do that in a later day. This is how you daisy chain, right? This is how you measure the distance with this sensor. This is the CR04 sensor, the ultrasonic sensor. I will tell you how this sensor works. You have to use a library anyway. So when you trigger this pin, you have to send a really small pulse to this pin, and it is going to emit 8 pulses from this thing, right? We call this a transmitter. 8 pulses from that pin, and those things are going to go and hit some obstacle and come back to this pin, this receiver. We call these transducers. This transducer is a transmitter, and this is a receiver. When you give this trigger pin a little bit of a pulse from the Arduino pin of the Arduino, this is going to emit 8 short bursts, and those things are going to hit an obstacle and return back. And that time between that transmission and receiving is calculated, is measured from the Arduino using a function called pulse in. And then the time is calculated. You know the time, you know the hertz, you know the frequency of those bursts, and the speed of sound in air, you know that. And then we can control the distance, we can calculate the distance. So this is how you include a library to the Arduino. So we will do that when we come to Arduino. Sorry, no, even without a library, but it's easy to use the library. In this example, when some objects gets closer and closer to this ultrasonic sensor, these LEDs are going to blink, like light up more and indicate that it is closer, right? So these things are used in like parking sensors or like that. When a car is, or usually these things are used in aircrafts, not this circuit but a similar application. When aircraft is going to like parked on that human bridge, it has to be parked in exact location. So the flight sensors, anyway, distance sensors are used to measure that distance. So this is how you use that and the shift register, right? It is a bit complicated example, so we don't waste 8 pins for LEDs, but only 3 pins to send out the data to the LEDs, and we can even use 16 LEDs and still use 3 pins on the Arduino. Like that, there are nice things you can do. So this is how you control displays. This is a OLED display, organic LED display. This is a touch screen. This is what we call a next gen screen. That is a brand name anyway. So this is those monochrome displays, right? Like things from those old mobile phones. This is what we call the, like we call this a dry screen or a ink screen. So the nice thing about this is these text are actually ink, right? So there are little like pockets of ink under this display, and when you send signal to this display, those pockets are going to open and write things on the display. So the nice thing about this is you can even power off everything and still the text will be visible. So the importance is, if you are going to use these things for to indicate maybe a notice or something like that, you can update the display to write whatever you want on the display and turn it off, and still the text will be visible on the display. Then the other thing is, other like, not like in the other displays, these are like matte displays, so they don't reflect or refract. So these things are really, it's exactly like written on a paper. We call these ink screens, ink paper screens, or dry screens, many names. So it is these things are a bit expensive still, it's fairly new now, but it's really nice. Those things were used usually before in the Amazon Kindle and stuff like that. Anyway, now these things are available for the Arduino and Raspberry Pi. It's a nice application. This is what we use the Arduino LCDs. We call this 16 by 4 LCD. This is how you generally connect it, but we use I2C hat, so it is much easy. So to connect an LCD directly, you need all these things, right? You need a potentiometer, resistors, and stuff like that. But when we use this piece of gadget under our LCD, we can just plug it to the I2C line and use it, right? So this is what we call the I2C backpack. See, this is how the I2C communication works. This is how you find the I2C address of some device which you don't know the I2C address. So yeah, so these things are this is like the pretty much of the syllabus we are going to do in the next few days. So this is a 7 segment display, 7 segments, because we have 7 LEDs representing one number. This 8 digit, it can represent almost all the numbers we need, of course, from 0 to 9. And we have multiple displays. If we have multiple of these things, we can display any number we want, and there is a decimal point. We use a shift register to control this, but you can directly drive that, it's not a problem. So you need the knowledge of functions to do that. So we will do that when we are doing the examples. We will do that. So this is how you control a motor. I will These things are a bit more advanced. We include the transistor and stuff like that, so it's a bit complicated, but we will do these things too. I will demonstrate what all these components do. So, when talking about motors, a motor is going to take 9 to 12 volts, right? But the Arduino is going to output 5-volt signals, and the motor needs a lot of current to work. So, the Arduino is capable of outputting only 10 20 milliamperes maximum. So, you cannot drive a motor directly from the Arduino. Here is the Arduino. So that is why we use a transistor to switch this 9 volt on and off, so we can use it. These things are still, we cannot do these things. We need this circuit knowledge. This is how you connect. This is what I call that we can use the PWM to speed control. See, we are analog writing, and we can speed control. So this is how you control the direction of a motor and brake a motor with the Arduino, and even you can control the speed. But H bridge, right? This is called the H bridge. You can see this is like the letter H. That is why we call it the H bridge. When you turn on this switch and this switch, the motor is going to see the current flowing like this to this direction, and when you turn this on and turn these things off, the motor is going to see current flowing in this direction. So the motor is going to turn sideways like this. That is the use of the H bridge. See, that is how it works. This is H bridge IC, and it has two channels. You can control two motors with it, and you can control the speed too, which is really nice. These are servo motors which you can control the direction, and servo motors are usually used in model aircrafts to control the angle of these rudders and fins. This is a robot, a toy robot using 16. I think we need 16 or more servos for that. So there are many applications which, and the RGB LED example I told you the other day. I think you remember that common cathode and common anode thing I described the other day. So this is how you control the color, or just the color of RGB using 3 potentiometers. You can almost make any color on this LED using these 3 potentiometers. We will do that practical in the next week. So this is called the spectrum sweep. It is going to show us all the colors on the color scale in one sweep, right? So this is IoT applications which you can connect the Arduino module to the internet and write things and get things from the internet. So this is what I usually refer as a Raspberry Pi. You might have heard, I have told it sometimes. This is a Raspberry Pi and this is a microprocessor. This is much more different than a Arduino board. To program this, you actually don't need a computer. This is a computer itself. You can plug your monitor to this HDMI port. You can connect your Arduino to this HDMI port and program this looks really nice. I need to tell you is now that we have a little bit of a knowledge and we are having a lot of stuff to learn in the future. I want you to think about a project that you can do, and maybe you cannot do that yet, but you want to turn off your lights at night. You want to control your fan and your light from the you want to turn off your lights at night. You can automate that, right? If you want to control your fan and your light from the they have some unnamed buttons. Some remotes have buttons with no names on the bottom, right? Usually there are, at least there may be one. So these buttons actually work, right? They don't work for the TV, but these buttons work for the TV. So if you want to control your fan and your light from the think of a project that you find fun and useful, and suppose I expect you to do that. And if you come across any problem constructing that project, please contact us. We will help you. And it's a nice thing to do in this. This is like the holiday season for the school students and the others. You can find time and try to do that. It's you have to get practical with Arduinos to master that. Anyway, so try to do that. And if you have any questions, please do ask. I got 2-3 questions and almost answered everything. So if you are having more questions, please do ask. From the next week, we are starting our usual lessons and we are doing recaps like this, like frequently, so you don't miss out anything. And please post on our Telegram group if you have to know about something more, and if you need to discuss about another topic, please post that on the Telegram group and we will discuss that too. And if you have any more questions, now it's the time to ask. You can unmute yourself and ask, or post on the chat or anything. Right, looks like there are no questions. So anyway, we will continue the lessons from the next week. And still I need you to practice the things we did, and if you have any more questions, please post on the Telegram group and ask us. Yes, the package you bought from Thingabits is enough to do a small project. Yeah, I think that has a IR sensor too. So yeah, even you can do that. You can use that to build a project like that I told in the IR application. You can do that. Yeah, yeah, it's fairly enough. The other things you can buy online, and these things are actually not that expensive. The basic stuff, right? The basic quality and basic stuff you can, it's not that expensive. The language used in the Raspberry Pi, there are many languages. You can use Python, C, C++, C Sharp. It's up to you. How to connect the Arduino board to the internet, that is on the group. So To the internet, you can use a LAN, a local area network. You can use an Ethernet chip like the W5500, or you can use Wi-Fi. Yes, there are Bluetooth modules. Pick microcontroller lessons. We do, but we don't have enough students, and it is a bit more complicated than this. But the value of the crystal is what will happen. Yeah, of course, the timing will be derated. The timing will be like messed up if the value of the crystal is decreased eventually, but that does not happen really easily. If we get the if we like over easily, but if that happens, the timing is going to be different. That printed display, that is called the e-ink display, dry display, or there are other names. E-ink display is the usual name. About the PIC microcontroller, just because he asked, uh, that is programmed using mostly the assembly language, and it's a bit hard to understand. But you can benefit that if you learn that. But there are more things you can do with Arduino, and there are more advanced chip than a PIC microcontroller. The PIC microcontrollers are like big brothers of the ancestors of these Arduino boards and other MCUs. There are some still in use, but those things are eventually replaced by the Atmel family and the STM32 family. So of course you can learn that, but I am not sure if there are any commercial applications. For fun and knowledge, that is really fine. Any more questions? Right, looks like we don't have more questions, and if you do, post on the Telegram group. And if you think that we should discuss about another topic or something you are interested in, we can do so. Post that on the Telegram group. Right, so let's stop for today. Have a nice day, everyone, and good night. Stay safe. Bye bye.